everyone, welcome back to the channel. We've got another tube radio again to work on. I think a lot of you have been waiting for another tube radio. So to be fair, I haven't even finished the last one because I was working on the RR radio from 1935. And that one is not yet finished. I'm working on that project a bit in between other projects, just when I feel like it. I still need to finish that one off, and so there will be still a video about that one. But I'm just, well, not prioritizing that project at the moment. I just do it in between other projects, just when I feel like working on it. It has to stay a hobby, right? So I decided to start a new project because, hey, why would you be organized if you can work on different things at the same time, right? So this is an SBR R1. And this tube radio came as a part of a lot of about 20 tube radios that I bought recently. And they came out of an, well, you could call it an estate sale, or you can call it a barn find, whatever. There is a house close to where I live that needs to be sold. And the previous owner was a collector of all different kinds of hi-fi material. So I already bought all of the tube radios that were in there. And I'm still discussing with the owners on what we can do with the rest of the material, if I'm also going to buy it or not. But this is the first one that I'm going to tackle from the lot. Now, to be fair, a big part of the radios from the lot were not in great condition. This one is one of the worst. And it's really in really bad condition, and it's also one of the smallest radios that were in there, so maybe the least interesting one, probably. So, hey, I decided why not start with that one first, and if it is not repairable, then we can already get rid of it. So, as I said, this is an SBR. SBR was a huge brand here in Belgium. Now, the point of the video is not going into the history of SBR, but you have to realize that if you're not from Belgium and you maybe have never heard of this brand, it was really, really big here in Belgium. And to be fair, it still is a huge brand in the second-hand market. If you check for old radios or televisions on second-hand websites, then, well, the brand you will encounter the most is probably Philips, and second spot, I guess, will be SBR. SBR was originally created, I believe in the 1920s or 1930s, as a sort of reaction against Philips, because the Belgian government was getting a bit nervous about the fact that Philips, which was a Dutch company, or which is a Dutch company, was gaining so much market share in this new technology, which was radio, and which clearly was becoming very important, and they didn't want to have Philips swamp the entire Belgian market, so they created SBR as a sort of, well, competition for Philips as a counter reaction, and it really succeeded to gain quite a bit of market share compared to, well, other Belgian brands which remained quite small. And then later, of course, they also got into televisions and other type of equipment, and then in the end, when things started going downhill for consumer electronics in Belgium, ironically, they were bought by Philips, and they were owned by Philips for quite a while, and they lived on just as a brand, but not as a manufacturer anymore until, I don't know exactly, maybe somewhere in the 80s, beginning of the 90s, when it was completely dissolved and the brand ceased to exist. But yeah, they were huge in Belgium, and they never really have been a cheap brand either. So even though this is a small radio, this is from this model here, it's the smallest and least expensive radio. It cost at that time 2,350 Belgian francs, and I ran the calculation. I converted this to euros and then corrected for inflation, and this is more or less equates to 500 euros or 550 euros, $600 more or less in today's money. So it's still not quite cheap. I mean, there were definitely cheaper brands available, especially if you know that this thing only has long wave, medium and short wave, so no FM. And now granted, FM only started to, well, be broadcast seriously in Belgium as of 1960 or 1961, I believe. In Germany and in the Netherlands, they were much earlier with FM. But still, no FM, and only 3 tubes. We'll have a look at that when we look at the schematic or when we look inside. But it's quite a simple radio. We'll see that in the schematic. The cabinet is made fully out of plastic. I don't think it's Bakelite. It's a sort of plastic. And yeah, the shape is not great. And the biggest issue is it has a crack here on top. See? See, so the entire cabinet here is completely cracked. There is also a crack here, a piece out of the cabinet. That's not that much of a deal. It's on the back, but this crack here is a big issue. And I noticed that the backplate just fell off. So see, there you have it, SBR R1. I'm just gonna put this aside and we can have a look at the back. Now I already blew this out a bit with the air compressor because it was incredibly dirty. Yeah, so see here you can see that crack in the cabinet, which is not great. I'm just gonna put this a bit closer to the screen and give you a bit of a closer look. See, so we have a couple of tubes. So as I said, 3 tubes. So there is one tube, and here is another one, and there is one. You cannot see it here behind this transformer can. There is here the tuning condenser. Yeah, the dial string is broken, so that won't work. No transformer. This is a hot chassis radio, transformerless design, and quite a bit of rust. Now not all of this is rust. I mean, the chassis, it has a golden color, but there is quite a bit of rust here on the chassis. There also on the output transformer, quite crusty. Not the greatest of shapes. So we'll see what we can do. I mean, I'm not 100% sure yet how far I'm going to take this restoration. We will see. That component or that capacitor is completely baked. Yeah, so here on the front we don't have a lot, right? We have, I don't know what this is. I mean, it's not labeled. The buttons are not labeled. I'm now looking here at my screen of my cell phone, which I'm using to film, and it looks great on camera, but in real life it is super dirty. And yeah, here there's also the SBR logo, which is missing. We're not going to be able to do anything about that. I think this might have been the tuning, and this is then the volume, but that's it. There's not even a tone control. Can you imagine? No tone control, no FM, just 3 bands and 3 tubes. It's really, they really went all out to cheapen this thing as much as possible. Okay, let's have a look at the schematic. You will see that it's super simple. I don't think it can get much simpler as this. So we have 3 tubes. We have a UCH81, a UBF80 and a UCL81. As you know, the tubes are starting with a U, so that means that they have a 100 milliamp heater for use in series mode for transformerless radios, hot chassis radios. My last video about, or my video that I made about the naming of tubes and identifying a unknown tube, I got quite a lot of positive reactions on that, so I will go a bit more in detail again into these different tubes, what they do and what the namings are. So we have here our mains plug, our on-off switch, double pole, and then here we have one side of the mains voltage going here straight through the, well, the 3 heaters of the 3 tubes and the dial lamp. They are all in series, and the dropping resistor. Then we have here our voltage selector, and then here this little guy, that's the rectifier. So we have just one diode I guess it'll be a selenium diode for the rectification. So we have very simple half-wave rectification. Then afterwards, the schematic is a bit weird, so I have to warn you a bit. It could have been drawn quite a bit more simple and more unreadable, let's say. It's a bit convoluted, so it is even more simple than it looks. So you have here the B+, then we have, it goes down, we have one filter capacitor over here of 50 microfarad. B+ goes here through the primary of the output transformer, as usual, to the anode of the output tube. So the output is a UCL81, the output tube. As I said, the U means 100 milliamp heater. The C is a triode section, and the L is a power pentode section. So this tube is the driver or the preamplifier, whatever you want to call it, and the output stage in one tube. So the L part, the pentode, we use this here as the output. And then, where does the B+ go then? You see here we have this dropping resistor, 2K, and then again a filter capacitor of 50 microfarad. And then where do we go from there? 100 ohm resistor to the screen of the pentode. And then there is another resistor here, which I cannot read what it says in terms of value. It says M2, no clue what it is. A resistor 88. It goes to the anode of the triode section of the UCL81. And then we continue, then we here have a capacitor which is labeled incorrectly. It's labeled 100 microfarad. It's not 100 microfarad. The electrolytic capacitors here on this drawing, they are drawn with these triangle shapes. So you have three of them, see 50, 50 and 10 microfarad. These guys, those are, I believe they will be paper foil capacitors. And the guy who drew this schematic had a bit of a brain fart because he indicated all everywhere microfarad instead of nanofarad. See, because 100 microfarad should be 100 nanofarad here. Same thing, 10 microfarad should be 10 nanofarad. 1 microfarad should be 1 nanofarad. See, all everywhere here as well. These caps, they are drawn incorrectly. They should be nanofarads. The ones which don't have a indicating in terms of microfarads, I guess that those are picofarad then. Anyway, then, now let's look where the B+ goes then. It goes all the way to here, down, through this switch. This is the pickup switch. So this radio does have a input for a record player. And they conveniently decided to put that switch all the way here on the left of the schematic, which doesn't make any sense at all. They would have been much more readable if they would put this switch, which is the pickup switch, all the way over here. But anyway, who am I to decide? So if you do not have pickup pressed, then this switch is closed and the B+ simply continues like that. Over here, goes through this IF transformer to the anode of the UBF80. Now, the B stands for a double diode with common cathode, and the F is a small signal level pentode. So you see here we have the pentode, and then here we have two diodes. So those are this is the B section, this is the F section of the tube. The diodes are used for the detection of the AM. The pentode here is used as an IF amplifier. Now, if you look carefully, you'll see that one diode here is just simply connected to ground, and the cathode is also connected to ground. So this diode doesn't do anything. They are only using one of the two diodes of this tube. The reason is they only need one diode for the AM detection. And, well, the second diode of this tube was originally intended for rectifying the AGC voltage. So, yeah, for automatic gain control. And they don't use that over here. So they don't have automatic gain control, I guess. or at least not using the diode. Normally, wait, let me see if I can show you in my book. Yeah, see, so there are 3 possible example schematics here for the UBF80. I guess this is the one that they use. This diode is unconnected. See, so here you have diode number 7. And the output of that goes here through this resistor AVR. AVR is Dutch for AGC. So, yeah, here they simply don't use that. So it's even a more simplified circuit for the UBF80. Now, the reason why they didn't use a UAF80 or something like that is simply because that tube doesn't exist. There is a UF in the Rimlock series, UAF, sorry, but in the Noval tube series, there is no UAF tube. So, yeah, they had this excess diode here, which they just don't use. Anyway, then the B plus here goes through this resistor of 15K to the screen of the UCH81. The UCH81 is, quite frankly, the same tube as the ECH81, but with a different heater. So it has the C again, that's a triode, and the H is a, what is it again? A heptode? Yes, I believe so. And that one is the mixer oscillator. So the C, the triode, is used for the oscillator. The heptode is used as a mixer. And the B plus comes in here like that. See, through this 25K resistor to the anode of the triode for the oscillator. And then here to the screen of the UCH, of the heptode for the mixer. Now this section over here, that's the oscillator. So that one really, if you tune, this is the oscillator frequency that's changing. Your antenna is over here. This is the ferrite rod. Signal comes in from that side to the mixer. And then here internally, see the grid of this oscillator is internally connected to one of the grids of this heptode. So you mix these 2 signals together, the oscillator and the signal coming from the antenna. That's it. It's really super simple. Now this lineup of tubes, UCH81, UBF80, UCL81, is very common. This trio of tubes, you see it quite a lot with smaller radios, which are transformerless from this era. The only thing that you then also see is a 4th tube for the rectifier. So most of the radios that use these 3 tubes, they also use a 4th one as a rectifier. But this one even cheaps out there because I believe that'll be cheaper than a tube. So we have only 3 tubes and then a selenium diode as a rectifier. That's it. It's really super simple, and let's have a look back to the radio itself. Okay, now let's have a look how we can get this out of the cabinet. Let's see, this is the power cord, which is partially janked up in there. Now, the cabinet is somehow screwed in, probably on the bottom. Let's see if I can turn this on its back without breaking it even further. I have a feeling that my desk is gonna be very dirty after I'm done with this. Now, the back panel was only in with still 1 screw, which I lost when I think it has fallen in the radio. Wow, what the hell is falling out of this thing? Anyway, I think the screw has fallen into the radio, and yeah, I guess I'll find it. So there are screws here underneath these feet. So they did take the effort to put small covers on the screws. I don't know what the use is of that. Yeah, probably because it's metal, right? And we have a hot chassis radio. Yeah, of course. So they put some plastic caps on there. One of those has fallen off. That would be a nice surprise if you pick up this radio and it has a hot chassis. So let's take these off. Let's take these screws off. What surprises await me inside here? Well, the Philips, I recently, or a couple of years ago, I restored a Philips which had a hot chassis, and that one didn't use screws to hold it in the chassis. Oof, that one is stuck very well. It's already dropped here. Yeah. Oh man. Oh, jeez. Oh yeah, I am done. I forgot to disconnect the speaker. Oh boy. I already see a cracked capacitor. I see a capacitor which is dangling on one leg. That's nice. I was so stupid that I didn't disconnect the speaker. God damn it. Yeah. Boys and girls, if you do this at home, disconnect your speaker first. I can do it like this. Right. Let me just unclip that one. Where's the other side? It's really all the way up there. Son of a... Okay. That's better. Whew. Wow, look at that. This capacitor is completely split open. This one here is just dangling on one, it's completely deconnected or dangling on one leg. Jesus. The dial cord is snapped as we expected, and for the rest we have quite a bit of dust inside, some spider webs. But at least it doesn't look complicated, because it isn't complicated. This is interesting. These caps are from the brand BB. And I think those are the same brand as my RR radio, which I recently, or which I'm still working on, which I recently restored, I wanted to say, but I'm still working on. So let me, see, so these are the caps from that radio. Now, these are 20 years older because this radio is from 1935, and see, they are also branded BB. Now, I haven't been able to find anything online about this brand of capacitors. If anybody knows where they're from, yeah, this is simply the dial cord that has snapped here. This is the volume control that's still turning. And for the rest, there is a lot of dirt and a lot of rust as well. See, so there, I believe that's the selenium rectifier underneath. How am I gonna start on this? I guess cleaning these up will be the first thing that I have to do, because this is just, yeah, impossible to work on in this condition. Okay, first things first, let's check the output transformer. This is the secondary. And I'm having a bad connection here because everything is so corroded. Whoa, that's almost a short, so that seems correct. And I think that this is the other tabs here is the primary. Not completely sure. And if I can get a connection on those. 475 ohms. That looks to be okay. I think the transformer is okay, the output transformer. So that's already a good start. Okay, so this is the UCL 81 Telefunken. And this is the UCH 81, also Telefunken. Okay. And here, all the way in the back, with the shield, we should have the UBF 80. That shield is obviously attached to the chassis. So I am going to try to get this out. Wow, this is a tin shield. Never seen that before. A feeling that I'm gonna need to wash my hands after this. And it's also a Telefunken UBF 80, so that makes me suspect that these are all three the original tubes still in there. So yeah, I'm just gonna get these tubes to the tube tester, and then we can check if they are still okay. Okay, the results are in, the tubes are tested. I didn't show this on video because I've already showed quite a few times on my channel the way that I test my tubes with my tube tester, so I didn't want to bore you with that again, especially not for this small radio. Well, if you like seeing it, let me know and I will show it again next video, but yeah, I don't want to bore you guys with that. So I tested the tubes. Here are the results. The UCL81 is okay-ish. The pentode section, plate current of the pentode and the triode are both very good. The only thing is the mutual conductance of the pentode is not that great, but I don't think that matters a lot for an output, right? The triode, now that is surprising. It measured at 240%. Not sure what's up there, but the manual of my tube tester showed for this tube the anode current for the triode at 0.5 milliamps, and I measured 1.2. So yeah, I guess that's fine. The UBF 80 is near damn perfect, so that's great. The UCH 81, the heptode for the mixer is also near damn perfect, but the triode, so that's the triode which is used in the oscillator, that one isn't great. See, it only measures a anode current of 67%, mutual conductance of 71, so that is borderline acceptable. I don't know. Now the thing is, this tube, I have it in stock. I have a working one in stock, so if I do have any issues with this tube, I can easily swap it. My experience is this is the equivalent of the ECH 81, and they often go weak over the year because these are tubes, they are driven, as far as I can tell, often quite hard for both the triode and the heptode. I've had these already go weak in a couple of radios that I restored. So this one we might need to replace. But the other two, I guess they will still be okay. Okay, so I removed the dial glass and this diffuser that was located behind. And as you can see, the dial cord is snapped. Here is the pointer. It looks like the dial cord is pretty simple. You just have here this wheel which is attached to the tuning condenser. This is the dial knob. Then you have one pulley over here, one pulley over there, and that's about it. So I guess we need like a couple of turns around the dial knob and then here across this pulley. Looks at first sight not too difficult, luckily enough, because I don't have a drawing of this, yeah, how it should be. Now I also tried to clean it up a bit, but it's such a mess, this chassis. There is rust everywhere. It doesn't even look like I have done anything, even though I did clean it up already a bit. But yeah, let me know what you think in the comments. Do you think I'm crazy to even start working on a radio like this? I don't know. I'm never going to be able to make this look good because, see, it's all rusted. The dial glass, let's start look at the positive points. The dial glass is in pretty good shape. I cannot see any damages. It looks okay. The way that it was fixed on there was quite interesting. So you had this diffuser which was sitting like that. The dial glass was simply in front, and then you had these clips or these pieces of metal that were just pushed in there like this. See? And then the edges, they were twisted a bit so that they couldn't fall out. That was it. It was only a matter to twist the ends straight, and then you can just pull these links out, and everything came out easily. So that was interesting. What else do we have to say? Not much, apart from the fact that there is a lot of rust, and that I'm gonna go ahead with cleaning. If you think I'm crazy, let me know. If you don't think I'm crazy, also let me know, because that's always nice to have a bit of a confirmation that you're not crazy. So, just gonna let you in a bit here on the joy. The amount of crud here on this chassis is insane. I mean, the more that I clean it up, the more I start to realize that originally I think it would have looked quite pretty. See, it is like a coppery color, but it's quite bad, the state. So I also don't know what this is, this dirt that is sticking on there. Maybe it's mouse droppings, but I'm using, well, disinfectant cleaner. So most of you will not really like seeing what I'm doing here, spraying this cleaner on top of the chassis and on top of the components, but hey, I don't think there is a better way of doing this. It's all or nothing here, I guess. I don't think I can make this a lot worse. Yeah, I decided to just start focusing on one particular area and try to get that sorted out, because this radio is such a mess, well, the condition, that it's a bit demotivating to work on it, because you spent a lot of time cleaning. I spent now more than an hour cleaning, and you almost don't notice what you've done. Well, if you compare before and after, you'll see the difference, but it still looks bad because it's in such a bad shape. Well, but I decided to start on the power supply, as you normally should always do. I took off the output transformer here from the chassis to be able to access this area a bit better. And there are a couple of things of interest here. So this is the incoming mains power. And then it goes through these, well, I can put the schematic here on the side. It goes through these coils. I measured them for continuity. They are still okay. And then it goes here through the fuse. So here was a fuse that was a 2 amp fuse. Now I don't know if that is an okay value. I don't have any, there is nothing written on the back of the radio. There is also nothing written on the schematic in terms of fuse value. So that was a 2 amp fuse. Then it goes to the switch. The switch is in the volume control. See? And then we have here the filter can, so that's a 2 times 50 microfarad. We also have this guy. That's a 100 nanofarad at 1000 volt DC. Okay, so that one is sitting just before the rectifier. So this is the rectifier diode. That's a Siemens selenium diode. And this side is the plus, and the right side over there, that's the minus. And then this resistor over here, that's a resistor which separates the ground of the circuit from chassis. See, on this side it is connected to the negative of the filter can. The filter can is isolated from the chassis. And on that side, this resistor, that's a 160 ohms resistor, is connected to chassis. So it's a hot chassis radio, but it's lifted above the chassis, let's say. It's a floating chassis. Then, yeah, this one cleaned up quite well. I measured it, it's still okay. Those markings are brown. And now they also look like brown, but earlier with my other lighting, when I had my lighting straight on it, I initially thought it was red, but it's brown. So brown, blue, brown, that's 161, 160 ohms. And this is interesting. See, this wire here has been worked on because this sort of, yeah, piece of protection wire or protection tubing was over here. So somebody must have worked on this at some point. I don't think it came from the factory like that. Here on the output transformer we have a resistor and a capacitor which are across the primary. So these inner ones here, so the yellow wire and that shielded wire, that's the primary. The green one, see here, this is the speaker connection, so the two outer taps is the secondary. Yeah, that's about it for now. I'm not sure how to continue. I want to replace this capacitor, these capacitors. I also want to replace the power cord because that one, let me focus if I can. See, that one is getting crunchy. So I want to replace that one as well. So that's the idea. First get the power supply sorted out. I'm also going to replace the selenium rectifier diode. I am not going to bother restuffing this can. The reason is this radio will never win a beauty contest, right? So I don't really bother that much about originality. I just want to see if I can get it working and working safely. Yeah, and it's really not worth spending so much effort on this radio to try to restuff this can. Just gonna take it out of circuit and put some other capacitors instead in the circuit. So yeah. So the amount of dirt that is baked on nearly every component is quite incredible. I mean, it's just caked everywhere. And I'm cleaning things up or trying to clean things up, and it's just not coming off. This resistor over here, that is the resistor between the two filter caps. So the entire B plus basically flows through this one, so I guess it will get nice and warm. So that's probably why this gunk has been completely caked on there, but it's just I have done in the meantime, I've been cleaning a lot, and I've also replaced already two components. Let me quickly show you here. See these guys over there. So this capacitor and that resistor, they are on the primary of the output transformer. They were both bad, so I replaced them. The resistor is supposed to be a 4.7K and it was 5.6 or something like that, so it went high. Now the resistor I put in here is only 1/4 of a watt, so that will probably not be enough. I don't have a higher value at the moment, so I will need to get some. But I don't know what wattage it should be, because it's nowhere mentioned on the schematic. So the idea is to, when the radio is working, measure the current going through there and then put an appropriately rated resistor in there. I put the output transformer back only with one screw, just temporarily, to be able to handle the chassis. That one over there, that's a 0.1 microfarad, 1000 volt. That's a bit exaggerated, I think. It's a paper cap, so I will need to replace it. The problem is that it's basically directly between the mains, across the mains. So I would like to replace that with an X2 or Y2 cap. I don't have those in stock, so I will need to pick one up. There is another one. There are a couple of caps in here that I don't really have in stock, which is a bit annoying. Yeah, sorry for the mess, but I think you will forgive me for this radio, that I'm making a mess here on my desk. Let me show you here the bottom part. I put the lighting on there correctly. What did I do? Well, quite a bit. I cleaned the switch, the on-off switch. That one was quite dirty. I also cleaned here the voltage selector, because that one also wasn't really making good contact. Those should be fine now. This guy over here, that's an interesting one. That's a 1 microfarad paper cap, I believe. So 1 microfarad, 150, 450 volts. I also don't have that. That's rather high value. So I will also need to pick some up over there. This guy is also super interesting, because that one is just floating in the air. And that's a 10 microfarad at 50 volts. So I will be able to replace, but there is definitely someone has been in here, because you can see marks of a solder iron here against this capacitor. This capacitor is completely cracked, by the way. There are also some masks of a solder iron on the cap that I took out, the one which was on the top of the output transformer. So somebody definitely has worked on this at some point. So now the idea is, if I want to go ahead with the power supply, that I start changing the caps here. But as I said, there are a couple which I don't have in stock, so which I need to pick up. Yeah, and then for the rest, cleaning, and again cleaning. Now the cleaning is not super, let's say, rewarding in this case, because even when it's clean, it still looks like shit. So this one is, now it's rather clean. All the dark brown that you see is all rust, I guess. All the gunk is off. Well, from this side of the radio, I haven't touched that part yet. So yeah, it's not super rewarding, because you don't really get a nice looking chassis afterwards. But hey, at least it's more or less clean, or it is a bit more clean than it used to be. Oh yeah, and I also already replaced the power cord, because I already showed you that one was quite crunchy. See, so I soldered a new power lead and a new plug, because the original plug was also super crunchy. I've never seen that yet. See, look at this. That one, yeah. So new power cord, new plug, but unfortunately I don't think I will be able to use it quite quickly, because I have still quite a bit of work. And there is also one of the leads here on this big resistor. One of the, well, wires broke off, and also the end of that wire was very crunchy. I couldn't even strip the isolation. It was that hard from the heat, so I had to cut it back and extend it again. I guess the same thing will happen to the other two leads. So yeah, it's a challenge. Oh yeah, by the way, I also cleaned the bulb, and I cleaned the holder. It's also very rusted, but it should work now, I think. Okay, so I put a new tag strip there. I just used a hole which was already existing and which was not used. to mount it to the chassis. The idea is to mount these electrolytics on there. So I have two 47 microfarad at 450 volts, which replace the two 50 microfarad caps in this can. So, and they are connected with their negatives together. So the idea is to put these on the tag strip and then connect their negatives together and then transfer these wires here to the positives of both caps. And as I explained earlier, the negatives, they are connected together, but they are not connected to chassis. They are connected to over there, so that's the one side of the on-off switch. So they are basically directly connected to one side of the mains. And then they are floating the chassis with this 160 ohm resistor. And this guy, the 10 microfarad 50 volts, should normally be between this point and chassis. So that's also isolating the chassis. The thing is, I'm going to replace it with this one. That's also a 10 microfarad at 50 volts. The difference is quite remarkable. Now, I can also put it on that tag because the middle pin over there is connected to chassis via the bolt that I'm using to hold the tag strip in place. So I can also just put it on there like this. It's connected with the positive side to chassis and the negative side to the common negatives of these two guys. So I should be able to take this one out simply and then put all these three caps on that tag strip. Now it's gonna require quite a bit of puzzling because I not only need to mount the caps on there, I also need to mount all these wires, so 4 wires, plus a wire to that point of the switch, 5 wires. I also need to mount those on there, and that's not gonna be easy. But yeah, we are not doing this hobby because it's easy, right? But honestly, I think I'm gonna leave you for this video, because well, I cannot finish the rebuild of the power supply anyway in this video because there are still a couple of caps that I'm missing. So I think I'll do that offline, and while I order and wait for the caps to arrive. Yeah, it's a bit of a sad state, this guy. It's a pity because I think it was quite a nice radio. Anyway, we're gonna do our best and see what we can still get out of this. Let me know what you think. Do you think I'm totally crazy? Or do you think that I'm doing the right thing? Well, we'll see. Anyway, I will work further on rebuilding the power supply, and I hope I'll see you in the next video. Take care. Bye-bye.